Hello. So trying to knock these questions out. This is Leetcode 250. So, two, sorry, 2,583. Wow. And there'll probably be more questions. My goodness. So this is the kth largest sum in binary tree, but and basically the question is asking, right? Like I don't want to read the question basically. So what we have is like we have level sums, right? So basically, five is on its own level, right? It will probably be level one or level zero, based on how you want to count it. But you can see note eight and nine, right? They are on the same level also. So I think maybe call it level two or whatever I want to call it. And then two, one, three, seven, also on the same level. Four and six on the same level. And now the question is actually like if you sum every element on each level, right? Which basically which level has the kth largest sum. So if we sum the levels, for example, now I want to go to that. Right. So on the whiteboard, you can see five, right? What's the level sum of this? Is five. Level sum eight and nine, right? Is going to be 17. And then we have 10 plus 3, which is 13, right? And then this level has a level sum of what? 10. Now, basically, the kth largest sum, right? So if we sorted, if we had these values, right, and we had them in sorted order, right, it would be 5 first, then 10, right, then 13, and then 17, right? So, ascending order. Now, what's the second largest sum here? Well, obviously, the second largest sum is what? 13. Right? It's one from here. Now, how do we get the second largest sum, right? Or whatever the kth largest sum is, we want to employ in solving this question is what we call a PQ or a priority queue, right? So a priority queue, depending on how you want to sort stuff, will sort it in, ascending or descending order, right? So we could have sorted it in, descending order where we have what 17 um, first, then 13, then 10, and then 5. Even so, we'll still be able to get what 13. But how would we get 13? Like, let's say we had this list. What we want to do first is say that, like, while whatever our key is, right, we've not reached that key. We want to pop stuff. So pop, um, for example, pop 17, right? We don't use 17, and then we come to 13, and then actually use 13, right? So basically, that's just the idea. We're going to employ a priority queue. And how do we get the level sums, right? So this question has like two parts in it, right? Like you using a priority queue to get the key at something, right? And how do you get the sums, right? Well, you get the sums by doing a breadth first search. That would be one of the best approaches. You can also use a map, right, and do a dead first search. You can, a map. It can be an int map, right? Like basically like this, or a custom hash map, whatever you want to do, and then do a dead first search, right? And then basically, would you increase the levels? You can probably do that. I think what will be easier is to do a breadth first search where we first have our queue, right? Like for the example with five, this example, right? Let's say we have our queue. Right, how are we gonna use it? So queue, we first take our root, we add our root there, and then we process five, right? Now, after processing five, what I want to do is to say, okay, now when I process five, I want to go towards five's, left child, right? So it's left child after processing five. This left child is eight, right? So you have eight, and then the right child is what 9. So this also is representing one value, one level, right? So the initial level will be just the root, right? And then once we are done processing, it's going to be out of our queue. But basically, then now our new elements in the queue, so 8 and 9, right? And you see, we process their children basically. So we take 8 out, process his children, right? So it's what 2 and 1, and then we take 9 out again, introduce his children, which is what 3 and 7. So you see these form levels, right? So basically, based on the levels, right, we can add what elements to so we can add elements and keep their levels basically, right? So we can keep their levels in the priority queue as I was saying, right? And then depending on the orientation of a priority queue, you can pop elements to find whatever element you are looking for, right? So that's how we're just gonna go about that question. Hope it's not like crazy. And hope the coding is as smooth as possible. Right. So basically, how am I going to use my priority queue? Well, basically, I want to keep it in ascending order, right? And then pop base, so that pop accordingly, right? Pop elements based on their size and stuff like that, and move on from there. So basically, I have a priority queue, and notice that the question is asking us for what longs. Well, I want to return a long, right, which is the sum. So I want to make a priority queue keep longs, right? So PQ, new priority queue. Then basically just going to be asking another, right? So after that, I also want to keep what a queue of longs. Sorry. Um, Actually, let me keep. Yeah, right. The longs. I can probably do that. No, no, no. In fact, let me keep a queue of three nodes so that it's easier to use. Right. So a queue of three nodes. So let me link this. Right. And first, for the first level, what I want to do is say queue dot add our root. Right. So we add the root first, and then we do our vector. So see while the queue is not empty. What we want to do is to first pop a tree node, and the tree node that we're currently dealing with actually like we might be dealing with, as I showed you guys in the example, we might be dealing with a set of nodes, right, at a time in our queue. So what we want to do is first to keep the size, right? So we want to keep the size of um, the queue so that we pop that number of elements from the queue, basically, right? And process, whilst we are adding its children and stuff. You get what I mean? Right. So then we keep the size, and then I want to keep basically I want to keep it as long as a sum, and long will initially be what 0, right? So the long is what we are going to be adding the elements in our level 2, right? So then we have a for loop for int I is equal to 0. Oh, sorry. I is less than sum and I plus plus. Now, what we want to do is to take a tree node, right? So we'll say tree node, and I'll call it current, and now it's called um, q.pull, right? So we pull certain elements, right? And then we add it to sum, right, for that level. So sum plus current.file. And now we add the children of the node. Basically, so if current.left, if that is not equal to null, right, then I'll say q dot add what current.left. Basically, you're adding a children, do the same for the right side, right? So if current.right is not equal to null, I want you to do is what q dot add what current.right. Cool. Basically, for that, everything is set. Now, when sum is done processing, right, we are going to add sum to our priority queue. But let's handle our priority queue sizes here, right? So now, if our priority queue size, right, I want to keep it at its size at k, so that we can, like when we are done, all we'll have to do is to pull our priority queue for the first element, which will be the kth largest element, right? So if our priority queue size is less than k, right? So let's see what our k is 2, right? Then um, we add to our priority queue, right? So you say pq dot add our sum, right? The current sum that we have, add the sum then. Else, if that is not the case, right, it's equal to k or it's greater than k, then I need to pop stuff, right? So else if, right, else if the priority queue dot peak, right, the first element in our priority queue. Now, if that is less than sum, right, then that cannot be what the kth largest sum. If you get what I mean, right? Because our priority queue is at most, at this case, in this else if, it has a size of what? K. Right now, if the first element is less than our sum, then it can't be the kth largest sum, right? Because we are looking at it in terms of largeness or greater size. So what we want to do is to take that element who is at the top of our priority queue, right? Take him off first. We say pq dot pull, and then we'll do pq dot add, right? So we add our new sum to it. So it's going to add the sum, and it's going to shuffle and find its place in our queue. And then what we want to do is once we are done, the question does say, right, return the kth largest sum in the tree, not necessarily distinct. And if there are fewer than k levels in the tree, right, return -1. how do we know that there are k or less levels in the tree, right? Then we can just use the pq.sum, right? So pq.size, right? So if our priority queue size is less than our k, then we know that there were at least k elements. Sorry, there were fewer than k levels, right? So we will return, right? So if our priority queue is less than k, right, then we return -1. So if this is the case, right, this probably never triggers, right? Because it's always less than, it's always less than, we're adding. In the end, we see that we have k less than k level, so return what -1. Else, what I want to do is what to return pq.peak, or you can even use the poll, whatever you want to do at that point, right? But I hope I explained it very well, especially with our management of our priority queue, right? And then submit. And basically, we are beating 98% of people. Very good solution, right? And I'm even thinking maybe I didn't properly explain the priority queuing, right? But let's say first we add 5, right? Like level 5, and actually let me just go to the drawing board. Right. First we add 5, right? Because this level is 5. Actually, let me just get a sums, right? So first we have 5 in our priority queue, right? And it's less than Q. Cool. Now we add what 8 and 9, this level, which is what 17. We add that to our priority queue, right? This is how our priority queue is going to be. Cool, cool. Now, the size of the priority queue is equal to k. So for the next command, it's going to go into our else if block, right? Where it's going to go, where we have to like move stuff. So let's say 2, 1, 3, and 7, right? That's equal to what 13, right? So now is 13, this sum, is it greater than our 5? It is, right? So our 5 can't be our kth largest sum. Like if we're looking at the kth largest sum, right? In this first instance, like let's say our k is equal to 2, right? Because that's the size, then our k will be what 7. So in this case, now we have 13 and we're comparing it with 5. 5 can't be, if 5 is not larger than 13, then it can't be our kth largest sum. So we want to take 5 out, right? So when we take 5 out, we have what 17, and then in our priority queue, and now I'll add 13 to it, right? So I add 13 here, right? And now the size is what k, right? And then we go for the next level. The next level is what 10, but 10 is less than 13, right? So if it's less than 13, right, and the size, k, what we want to do is that, 10 is less than 13. It can't be our k largest element, right? So what we want to do is what discard 10. We do not add it. And then this is our final priority queue, right? Which is 13 and 17. And then we just return what? The element at the top of the priority queue. Basically, that's it. So I hope it helps. But let's even first see if the code works, right? Pass, yeah. I think I already ran it, maybe deja vu, right? So we've run a 13, right? And it passes all the tests. I think it passed like 90, yeah, 93%. So I just ran it. Okay, cool. Now the question is going to be, right, at this point, what is the runtime of your algorithm? Well, obviously we are going to touch every element in our tree once. So let's say the size or the number of elements in binary tree is n, right? Then this is O of n basically, right? Forget about it, there be a while loop and a for loop here, right? We touch every node and process it at least once, right? So at most once basically, right? So first with the adding and then with the processing, right? So basically it's going to be 2n, right? We touch it at least twice. However, it's still O of n, right? So this is an O of n operation, and then managing the priority queue, right? That is interesting. Now, how do you the runtime for managing the priority queue is going to be n log n, right? Because it's n is log n additions, and I think it's with the pooling, right? If you have an element at the front of the priority queue, it should be of one addition and removal. But just because of how the priority queue works with the sorting and everything, right? There's going to be an n log n operation where n is the number of elements in. Oh, sorry. Actually, this is going to be k. Let me see the number of levels, right? So it's going to be k log k basically, right? So let's say we have k levels. So which one is going to be greater? Is it O of n or k log k? You decide. But basically, you can tell the interviewer like K log K plus an O of n, where K is the number of levels we have, right? The greatest number of levels we have, or what O of n is the number of sorry, n is the number of elements in our binary tree. Not to make the video too long, guys. I